Advantages here, you have optimized use of pumps and distribution. As I explained, it is increased comfort by delivering stable pressure in the critical points, and it also saves energy to a very great extent, and majorly it reduces the leakage. When you see why constant pressure system will have a lot of pipe breakages is, say when you don't have any requirement of water and the demand is very less, but still the pump is actually giving a constant pressure. In that case, the stress of that pressure will be there on joints of, in many cases, for the pipes. So the joints will actually break, and that's how the leakage will start. And uh, that is where the pipe bursts will happen, and most of the pipe bursts will happen only at the night, where the demand is less, but you supply a very high quantum of water. Okay, and minimize the risk of, of course, as I explained, minimize the risk of pipe burst, and minimize downtime. How? See now, in this case, you will be having a pipe burst. Say for example, you have a pipe burst, and then in normal cases, what happens is you never know how the where in the network is going to have a you actually have a pipe burst. Only when you know or you learn from a complaint which says that this is where the the water is getting leaking and it is coming out above ground. So then only you will know that this is going to be the place where the pipe burst occurred. Otherwise, if it is going to be a minor one and underground, so only when the sinkholes happen, then you will know this is where it has happened. So in this case, what happens is, when there is a critical sensor in that particular DMA or a node, that critical sensor will show that my pressure is not achieved at that critical point in that, or in that particular node. Then you will know, okay, because either because of leak or burst, something has happened. That is why the consumption is giving very high. So thereby you will know, okay, this particular node has some problem. We will attack that particular node. So that is how the minimizes the downtime. And then, of course, this is where the importance of critical point will come into the picture, right? So you can have a minimum of one critical point and a maximum of 10 critical points in the network. So this depends on the design and the modeling what we do. And I think this is my final part, which I think it's a pre-final part. So it is how it is suitable for Indian conditions. In Indian conditions, predominantly when you're going for water distribution, you will have two kinds of distribution. One is going to be timer based, and another one is proportional pressure based. Predominantly, we are using timer based. The same system can also be used for timer based. That is from morning 3 to 4, I will supply to this area, and 4 to 5, and then 3 to 4, 4 to 5, I will supply to this particular DMA. So those kind of things can also be used with the same pumping station. And of course, proportional pressure based is booming to a very great extent. So we are slowly working, I mean, most of the authorities are working with the pump manufacturers to actually understand what is this proportional pressure based system, because in CPHU also now it is mentioned that direct pumping with pressure monitoring at the critical points can be used. And some of the funding agencies are also specifying that you should use a pump based system. So in Indian conditions, yes, it is suitable, but still a long way to go. So that is what we are learning when we discuss with the end users, mostly authorities. So eradicating completely the overhead tanks is actually a big advantage, because for constructing that you will have at least 1 to 2 years based on the fund availability, contractor, and all those things. And project timeline, contractor litigations, many things are there. So here you are completely omitting that. Maybe in 4 to 5 months you can get that pumps ready, and you can actually fit it in the system and you can supply water for the existing ones. So this is one advantage. The results, yes, as I explained, 15% leakage saving, 25 percentage maximum on energy saving, and 35% reduction in pump pipe burst frequency. This is on a general scale where we have learned from our 100 proportional pressure system across the globe. So with this, I'm actually ending my presentation, and I can take questions. So hope I have given some good inputs on the concept.